What would happen if you fell through a gas giant? Would it be a thrilling adventure or more of a nightmare? This question comes from one of our Year 9 students and is what we're going to look at today. To help focus this video, I've picked Jupiter as our gas giant. It has had more missions to it than the other gas giants in the solar system, and as a result, we have a better idea of what is inside it, and therefore can find out what parachuting on a planet like this would be like. There have been several models of the internal structure of Jupiter over the years, with new findings on this from the recent Juno mission, which launched in 2011, reached Jupiter in 2016, and has been orbiting ever since, bringing back new findings along the way.
The current model for Jupiter separates it into four main layers. Up first, the atmosphere. This is the thinnest layer at around 50 kilometres and consists of mostly hydrogen and helium gas, with some water droplets and ammonia ice. The temperature ranges from -150 to plus 1000 degrees C, and the pressure increases massively from 0 to 1000 times the Earth's atmospheric pressure. This is around the same pressure that you would experience at the bottom of the Mariana Trench, the deepest point in the Pacific Ocean. From there is the outer interior. This is 21,000 kilometres thick and transitions from gas to liquid due to the intense pressure changes, getting up to 2 million times our own atmospheric pressure by the bottom, with a temperature at the bottom of 8,000 degrees C. The interior takes a further 40,000 kilometres to pass through and is mostly liquid metallic hydrogen and helium, with trace amounts of methane, water and ammonia. The pressure increases again, this time all the way up to 45 million atmospheres, with the temperature doubling up to 16,000 degrees C. And finally, we get to the core of Jupiter, which we think is solid, compressing around 30 times the mass of the Earth into a volume just 1.5 times the Earth's radius. Core temperature here gets up to around 32,000 degrees C. We used to think that the core had a firm boundary with the interior, but data from Juno suggests that this may be more of a graduated change than we first thought. Now that we know more about the structure of Jupiter, we can start to consider what parachuting on this planet would look like compared to Earth. If you are looking to do a parachute jump on Earth, it is critical to keep an eye on the weather. Most companies that provide skydiving experiences will not let customers jump if there are winds of more than 25 knots. This is approximately 29 miles per hour. As we can see from this simulation, when the parachutist jumps with no wind, no straight drop, though with high crosswinds, this is quite dangerous. Unfortunately, the winds on Jupiter tend to be significantly quicker than this, reaching in excess of 200 miles an hour in most regions, though storms at the poles can experience winds of up to 900 miles an hour. This is obviously much higher than would be considered safe on Earth, so it might be tricky to find a company which will fly you out to Jupiter for skydiving. You will also need to be careful of where you target your jump. If, for example, you choose to jump into the Great Red Spot, a cyclone wider than the diameter of the Earth, then you will have to battle against wind speeds of up to 425 miles per hour during the 320 kilometre descent through the storm. Not one for the faint of heart. One thing to consider is what resistive forces you will encounter as you fall. For skydiving experiences on Earth, they will generally not allow you to jump if it is raining. If you imagine hitting water droplets around 120 miles per hour, you can probably realise why this might be a bad idea. This is even worse on Jupiter, where the higher gravitational field strength could accelerate you to higher velocities, only for you to fall through those same water droplets and ammonia ice as you pass through just the cloud layer of Jupiter. Not only could this cause injury, but exposure to ammonia is not recommended.
It can lead to burning of the eyes, nose and throat, and in large enough doses this can be fatal. In addition to this, the different coloured bands on Jupiter represent where the convection currents rise and fall in its atmosphere, with dark bands called belts showing where the gas is sinking, and lighter bands called zones showing where the gas is rising. The speed of this is in the tens of meters per second range, which could lead to unexpected up and down drafts, giving further unpredictability to what is already a very dangerous fall. As I mentioned when we looked at the structure of Jupiter, the atmospheric pressure gets significantly higher than that on Earth. By the time you've reached the boundary between the atmosphere and the outer interior, the pressure has already got to 1,000 times that of our own atmosphere's pressure. This would be catastrophic for skydivers on Jupiter, as they would be crushed under the intense atmospheric pressure. This means that free falling without a very strong craft is not a good idea, and even then our strongest research submarines on Earth can just about cope with the atmospheric pressure at the bottom of the Mariana Trench, but they haven't been heat tested for doing that whilst they're at 1,000 degrees Celsius at the same time. Plain and simply, no. The winds make it too dangerous and would likely hamper the proper deployment of a parachute. The ammonia ice droplets could cause injury as you fall through them, and you would be crushed and cooked before you even got through the cloud layer of Jupiter. All in all, not a great experience. What I would recommend instead is giving this video a like if you enjoyed finding out about this as much as I did researching it, and considering subscribing to our channel for more random astronomy questions and videos each week. Next time we'll be looking at why we haven't discovered aliens yet, and until then, please continue to watch this space.